Hi, I'm Anya Monaco, and I'm here with Vint Cerf, one of the founding fathers of the internet and an IEEE fellow, and we're here at Sections Congress in San Francisco. So, Dr. Cerf, following your presentation, you must have had a line of about 60, 70 people waiting there to talk to you, get your autograph, snap their photo with you. How does that feel?
Well, it's an honor to have that kind of recognition from fellow engineers. I mean, this is very special, and I wasn't expecting anything like that, but I was very happy to accommodate.
So clearly you're a very big inspiration to them and to so many engineers and to so many people. What inspired you, or who inspired you to go into computer science and engineering?
Actually, my very best friend got permission to use the computers at UCLA when we were still in high school. Now, you can imagine at my age, that was a long time ago in the Cenozoic period. His name was Steve Crocker. We've been friends ever since. But I also had encountered in 1958 the semi-automated ground environment computer. It was a tube-based computer that was used to analyze radar traces coming from the northern part of Canada to try to detect Russian bombers coming over the pole. And I got a chance to see that machine at age 15. And I was instantly smitten. And by the time I got to UCLA as a graduate student, the ARPANET project had started, and I was part of Leonard Kleinrock's group, another IEEE fellow, and that's where we got very involved in networking, ARPANET to begin with, and then later Bob Kahn and I working on internet. So these people inspired me because they saw what was possible. And once you realize something is possible, then it's just a matter of engineering.
Mm-hmm. So why did you join IEEE?
Well, first of all, I consider IEEE to be one of the premier professional societies. If you're an engineer, especially in the field I'm in, you can't not be a member. You have to be a member. It's part of your professional responsibility. It also is a mark of distinction. And it's something that if you're looking for a job, for example, being a member of IEEE actually counts. It's a measure of your dedication to the profession.
Absolutely. Now, of course, you being one of the founding fathers of the internet, do you ever get tired of that phrase, by the way?
well, no. How could you possibly get tired of that? I mean, it's a wonderful honor to have been at the right place in the right time. But I do try to remind everyone, including you, Anya, that this sort of thing doesn't happen just because one or two people wrote an interesting paper. Thousands, hundreds of thousands, maybe millions of people have contributed to the creation of and the growth of the internet as you see it today, and it continues to grow. But all of its creativity comes from its users, and that's what's so wonderful. It's an infrastructure on top of which an unlimited amount of invention can happen.
And I actually want to talk a little bit about that. So these days there are so many methods of communication and reaching out and getting in touch with each other, from blogs, wikis, social media. How do you feel engineers and IEEE members specifically can make the most use out of all of these sort of new tools that we've got on the internet?
Well, so first of all, a lot of those methods, first of the technological ones, I mean, whether it's instant messaging or email or variations on that, then there are, and blogs and web pages, then there are the social networking activities like Google Plus, for example, or Facebook and some of the others. It's possible to create groups within those social networking conventions that might allow you to focus on a particular topic. Certainly in my world at Google, the Google Circles are intended to do that. On the other hand, there had better be a good reason for forming this kind of social connection. Projects are often a very powerful way of organizing people's interactions. And this is an area where I am deeply committed to the notion of collaboration. It's something I want to emphasize, especially that we're here in the connection, or in the sections meeting, is the diversity of engineering within IEEE and the importance of bringing all those disciplines together. Disciplines are an academic artifact. They were an organizational structuring artifact. But the honest truth is all these disciplines interact with each other. And we've seen that in this morning's presentation by Moshe Kam about the diversity of IEEE and the things that it does and the topics that it touches and now the bioengineering aspects. What that tells me as an engineer is that if I want to have an impact, I had better be prepared and encourage people from other aspects of this discipline to work together. So I would be looking for these social networking tools, the web pages, and all these other things, including the My IEEE member page, as a tool for discovery of other people whose interests and whose skills are important to the projects I work on.
Now, with all of these great aspects of the internet, increased connectivity, there are also some concerns that arise from that. And it seems like there's a growing concern for privacy and security. And especially with security, you've got groups like Anonymous. It seems like there are increasing amounts of hacks happening. People are concerned about their privacy. What do you feel is the biggest concern involving the internet that we really need to pay attention to over the next few years?
So the sort of very top level assessment is that this is not as robust as we would like it. Although the internet is remarkably robust given its age, and it was designed 40 years ago, and it's still basically the same way, although I have to say it's elaborated dramatically in the 40-year period. On the other hand, any complex system has vulnerabilities, anything that is as complicated as the internet with as many moving parts, which means that as engineers we have a responsibility to do an increasingly solid job of system engineering. That includes rooting out vulnerabilities. It includes making commitments to software that will resist various forms of attack, introducing security technologies that will help keep the network more stable than it might be today. There are security mechanisms going into the infrastructure. The domain name system security, digital signing, DNSSEC is part of that. Something called routing PKI is another example of the use of digital signatures to prevent people from hijacking internet address space and pretending to be owners of addresses that they don't actually own. Use of strong authentication, use of strongly authenticated identifiers are all methods for protecting people from being fooled, from being defrauded, and from being routed to the wrong place. But there also is a certain amount of common sense that needs to be applied here. You shouldn't be clicking on attachments that show up on messages that you don't recognize from people you don't know at all. So we need to make people more aware of the risks and how they can defend against that. But that does not relieve the engineers of the responsibility for building an increasingly secure, increasingly reliable network infrastructure. If we rely on this for more and more things as we have, then when it doesn't work, there's a lot of potential bad side effects. So this is like every other engineering enterprise that I can think of. The more we depend on it, the more important it is, the harder we have to work to make sure it works and protects people and keeps them from harm.
So many things have changed with the internet in the past decade and even beyond that. What does the internet of 25 years from now look like to you? What do you think we'll be seeing and doing on the internet, and how will we be using it?
So we can make some predictions with trends today. One of them is that many billions of devices will be on the net, not just people carrying those devices, but things that are embedded in appliances around the house or in the home or in the car or on your person. Sensor networks will be everywhere because we want our systems and our buildings and everything else to be aware of energy consumption, aware of the environment, aware of potential hazards that warn us of problems. So we can anticipate large numbers of things on the net. Second, I can expect much higher speeds to be available. Some of them may be as a result of optical fibers, some simply much higher frequency, like 60 gigahertz transmissions on radio. Third thing that is almost certain to happen is that the internet will go off-planet. I've been working with the Jet Propulsion Laboratory, NASA, and the other NASA laboratories on an interplanetary extension of the internet. We are well on our way to standardizing that. We have it on board the space station. Prototypes are operating on Mars. We have a spacecraft that's rendezvoused with two comets called Deep Impact and Epoxy. We've tested the interplanetary protocols there. Once they're standardized by the Consultative Committee on Space Data Systems, we hope all the spacefaring nations will use those protocols. The side effect is that the spacecraft will be able to communicate with each other, and more important, when they've completed their primary mission, they can be repurposed as nodes of an interplanetary backbone. Now, people will say, well, are you expecting the Martians to communicate? Of course, the answer is no, but I do expect more robotic and ultimately manned missions to take place around the solar system, and we need to stay communicating. We need something better than just point-to-point radio links. It doesn't stop there, however, because once we see the possibility of an interplanetary scale networking with sensors and the like, then we should be thinking, well, what happens if we mount a mission to the nearest star, like Andromeda, which is about 4.4 light years away, pretending that we can actually get there in a reasonable amount of time. And the Defense Advanced Research Projects Agency just scheduled a conference on the subject of the 100-year spaceship to get to the nearest star, which requires propulsion capabilities that don't exist yet. This raises the communication problem. If I'm 4 light years away, how do I communicate back to planet Earth? And one answer may be, well, you may have to communicate to a sensor network which literally spans the solar system in order to detect the signal, which will have expanded. A light signal will have expanded over that propagation distance. So, Internet is, or its descendants, will be off-planet and maybe even beyond the solar system. Hi, I'm Vint Cerf, an IEEE member, and you're watching IEEE TV.